Thank you very much for inviting me here to present today. I'm in a particularly interesting position here because I'm a mathematician who works with computer scientists. I behave like any other academic, yet I work for Microsoft, which is an industry leader in software. And so what I learned today was really, for me, an excellent insight into my presentation today, because I will be trying to answer some of the questions. Let me just mention a couple of them. There was an issue of authenticity, what authenticity means for digital, and I hope that presentation will give some insights about what might be defined as authenticity. Also, about the technological aspect. We know that sustainability, economic sustainability, is one of the important issues. The question is, how can we achieve this through technologies that are now available to us? So let me start with a simple position. We know that digital has changed our life tremendously. It's empowering. However, we are facing challenges, and today we heard a number of them. One is about longevity. So the second question is, what is it about digital what we need to know in order to start reasoning about what it means ensure it access in the future? So in the presentation, I will try to do two things. First, reflect a little bit on the digital revolution and what it means to us, and why is it so different from the previous ones. And the second, then talk about economic models and sustainability of the digital. In the first presentation, just a quick overview of what has happened to us. We have seen in information technologies a number of revolutions in the past. The pamphlet that's included in the conference shows the evolution of the physical medium that we used to use for transferring information. With digital, everything is in the digital form. It's essentially bits encoded thanks to advances in electronics. So we know that this is a medium that is very sophisticated, not accessible to us as humans immediately. So we need to reflect upon what actually it means. The reason why we can benefit from digital is because we can encode information, and we can also encode computation. Together, information plus computation gives us something that we humans cannot do. So in a way, digital technology is a really way of enhancing our human abilities to do things that naturally we can't do. We can integrate information, we can compute at unprecedented speeds, and we can share information as well. So this is the question: how do we leverage computation to take advantage of these particular properties? Okay. Now, just a couple of examples. What has happened to us with digital information, we have spun out new types of sciences. I'm just aware of, say, nanotechnology. Nanotechnology would be completely impossible these days unless we had sophisticated laser equipment, for example, but also computing technology to translate the signals into something that we humans can read. So there's types of sciences that would not be possible at all. Now, just looking at the data gathering scales. This is taking just an example of the Large Hadron Collider, where we are pushing the boundaries of physics and looking at the information that's being stored. 1.5 terabyte per hour is being generated. If you look at the Atlas sensor of the collider, it's 1 petabyte data per second. Where is that possible? Which other infrastructure can handle it but digital ones? Similarly, the next thing that we would love to do is map out our brains. We want to understand how humans actually think. And we've cracked the DNA. You can now get your DNA analyzed online. You just ship it off. Now, the next thing is, the next frontier is, can we actually understand our own brain? Well, we could, but look, there are so many processes that we need to model. And we need to think about the computing technologies that would enable us to do this. And we have done over the years. We have progressed in the infrastructure to support computation. For example, we had supercomputers in the past. If you remember, I remember punching the cards and taking them to the supercomputer center at the time. But then we progressed since then. Now we are looking at the farms of computers and distributed processing. We're also looking now at the cloud technologies that are enabling us to have resources on demand. And just to unpick a little bit this, perhaps to make concrete a little bit more what cloud is about, it's nothing else but a data center that has lots of computers that are then wired and then a certain computing routines run in order to do the distribution of processes and so on, so that we can have it at a cheaper, rate, and then we can also leverage the computational power. So that has been the kind of the progress of, at a high level of digital. But then let's just look at it, what it means for digital artifacts that we create. Often we think about digital, and believe me, in this community as well, I hear a lot about format conversion. Why is it? Because the file has been offered to us as the primary container of digital. However, as I just said before, digital is fundamentally computational. I cannot really see anything that you put in the file unless I can run some software to interpret it for me. And we should not forget that. And my presentation here today is really about that. We heard about IT and often think about IT as migration support. But in fact, what we need to think and talk to Microsoft and Apple's and Google's and others, we need to talk to them about computation. We want some commitment on the computation. And just a little bit, why file is not enough. If I give you the same HTML file, I'll give you 2 browsers, guess what's going to happen? You're going to have different layout. So the computation just it shows you that computation is the one that actually determines what you're going to see on the screen. So the proposition here is, when you think about digital, you have to think about both, the file and the computation. So why are we then just focusing on files? We need to think that we need to sustain computation. And I appreciate very much why this proposition was not on the table, because it wasn't in your control. You used to buy a license for software, and guess what? After three years, Microsoft was going to ship another software, and then guess what? You're going to buy a new one. Nobody's asking about the previous one. Now, of course, Microsoft doesn't want to aggravate you, so they'll do backward compatibility for a while. But whenever you have a new innovation, you have to abandon the old format. Innovation is impossible by locking things. We are now moving into devices that are going to use speech and gesture. Would that be recordable in the old format? Probably won't. We will have another set of innovation that will going to push this. So therefore, we cannot stop innovation. The question only is, what can we do? Is it possible at all to sustain computation? And then just let's unpick a little bit where the problem is. Why is it the case that my program cannot run? What is the problem? I paid a license, I had it on my PC, why is it doesn't run? The problem is that the ecosystem around it is very complex. So any software application, unfortunately, relies upon the whole stack of applications. The operating system, the driver for your printer, the driver for your screen, the driver for your mouse, so name it. There are many, many different things that sustain it. Okay, so the question then is, all right, what can we do? We cannot ideally save all the software, but pragmatically, what can we do? So in a way, what we can, when we're looking at digital artifacts, we can decide what is it that we want to keep unchanged. Okay? I just want to comment on the migration strategy because that's one very, very common. And I want to just bring it home what actually is happening with migration. When I have a file, I'll take an example of WordPerfect file. And my WordPerfect application doesn't run anymore. And I decided to turn it into PDF. What have I done at that moment? I have basically given up on the original file, and I have given up on the original computation. I put all my bets in a new format, say PDF, betting that somebody is going to provide the software to read it. Okay, so all I've done is kind of push the risk, and I'm making a bet that ecosystem will somehow provide computation. Okay, so just so we understand that clearly. If I, for example, do not want to give up on my file because it has my book in it. So WordPerfect file, my book in it, worth $1 million. I don't want to give up on it. What can I do next? Well, one thing I can do is beg somebody to port WordPerfect into a new contemporary system. It will cost me lots of money, the whole $1 million, maybe even more. Okay, so in a way, what I can do is I can push the development, I can invest in development to port the software into the new environment. And I have to keep doing this because the system is going to change, the environment is going to change. And the last thing is when I say, I'm not going to give up on any of this. I'm not giving up on file, and I'm not giving up on computation. I will make somebody keep it alive. And at the moment, we have technologies. VM technologies offer that to a certain degree. But you have to understand that VM doesn't really change the equation. You still need to maintain the VM. Okay? So in a way, if you just look at it, it's all about cost. People are going to tell you everything is possible. You only need money and time. Okay? So whichever strategy we do, we will have to pay for it. Either you're maintaining VM, or you're porting the software, or you're implementing, doing transformation and implementing new readers. Okay? So unfortunately, the gloom and doom of this is it is going to cost. Okay. So one solution is, all I'm just saying is that perhaps there is some hope, a pragmatic solution, where we can try to see what it means sustaining software. Because if I told you that your job now is easier because you don't have to ever worry whether a particular file can be opened, then you can focus on many other things, the ownership, the legacy issues, the policy issues, and so on, curation, and everything else. Suppose that we can solve the problem of any file ever created can be opened. Okay. So how could that be possible? Only, of course, if somebody would maintain, we can lower the cost of maintaining this software somehow. Okay, and here's the proposition that perhaps in VMs that we are now supported in cloud architectures, you can create as many VMs as you want. You can provide a stack of software in it. Of course, you have to negotiate with Apple and Microsoft and IBMs and Oracles and whoever. Okay, but it's possible. It's not impossible. So what would then be the job? You can do the VMs. But that's not enough, because you still need to connect that software and file with the contemporary environment. I may have my WordPerfect book, but I want it indexed by Google. So how am I going to do this now? I have to provide a bridge. So the text needs to be exposed somehow to new services. And that's basically the picture. The preservation is nothing else but enabling the continuity from the previous computation to new computation. Okay? So now if you look at the winning strategy, it is virtualize as much as you can. Again, be very pragmatic. It's not about the ideal thing. You cannot have everything, but don't give up on it from the beginning. And then you have migration services, and it's going to be the balance between these two. So I just want to spend the next 5 minutes showing you it's possible because we implemented it. Okay, so the format transformation services on cloud, we built that as part of the SCAPE project. SCAPE project is a European project which involves a number of partners, libraries, archives, universities, and vendors who are providing preservation strategies. So we built a simple workflow. This is really high-level workflow where you can ingest the data, you can decide what you want to convert, you can run some tests to see how well you've done on the layout, because I want to argue here is that people most of the time focus on the layout. They never ask me about the structure, what they've done to the structure of the document, which is actually critical for exploitation in other services. So how does this look? This is not to frighten you. This is just to bring home what it means implementing this in a cloud architecture. So in the cloud architecture, you can create this, what we call worker roles, and each worker role can do some operation. So you can do transformation, comparison, whatever, you name it. Analysis is extendable. You can fire off any number of these to process as much data as you want. And then here's the interface. So you can go in, you can convert the documents. I can convert everything into everything else. So this is one example where I'm showing that because it's cloud, I don't have to decide what's going to be the standard. I just fire off any conversion I wish, because it will depend on the context and where I want to extract value further, that I will need a particular format. I'm showing you this one here because this is deep zoom. Enables me to see my document on a mobile phone just by doing this, touch and gesture. Okay, so the value proposition there is I want to see it on my mobile phone instead of in a fixed layout on the PC. Then you can do comparison. You can ask whether your layout is okay. But I do not want this to be equated to authenticity. There is nothing authentic about the layout. Authenticity actually is buried in the computation plus file. Don't ask me that Word document and the Word application is the only authentic one. If you move it into PDF and PDF reader is not authentic, because it's the computation that determines it. And so digital artifact, anything else is just rationalization and then justification of where the value is going to be extracted. Layout is good for reading, but putting in a TIFF is incredibly inefficient if you want to do indexing. Okay. So also, as part of the service, we provide analysis of the collection, so we can tell you where the layout errors were assessed. So that was an example. It is possible. It is done. The second one, I want to show you the virtualization story. It is possible to virtualize. And here is the Windows XP running in a VM. And here's a little application that enables me to look at the documents. So in this application, I can import some documents. And I'm importing now Word 2.0, and then Word 6.0 document, and a WordPerfect 5.0 document. And now I can request to see it. And here it is, Microsoft Word 2.0. It's lovely to see it, where the icons are. Look at all black and white. Okay? So now what I can do is I go and say, let me convert all of this. Okay, here you go. I converted them, and I want to see them in OpenXML, because Office OpenXML is one of the standards. And I can see it now in a contemporary environment. And I can look at both of them next to each other. So it's possible. So why would we give up on virtualization? I'm not saying it's without barriers, but if we come, and I'm insider in Microsoft, if I can convince Microsoft to host this in VMs in the cloud, then everybody gains, I believe. We all gain, okay? So that's my job, by the way. I'm going on right this moment, okay? So essentially what I'm saying is the nature of digital is such that you cannot ignore computation. Now let's look at the question about who's going to pay for services. So even if I convince Microsoft to put all the VMs with all the legacy software, which wouldn't cost them much, okay? How would they sustain machines, and how would they justify service? Because the service will involve a number of IT personnel maintaining these machines. Okay, so but basically we are saying, from the preservation point of view, you can either do the maintenance of VM and supporting then on-demand transformation of objects, or you can go with your old strategy of migrating everything. But if you can combine the strategies, we can see how the cost is being spread. You can ask yourself, if you have millions and millions of documents in one format, and every time I need to transform them, would it be more costly than maintaining a VM where I can on-demand basically process the documents? It's a simple question, and we can probably sit down and calculate the cost, okay? So the question is, in general, who pays? I already said it's going to cost no matter what. At the moment, the technology users and content holders are the ones who actually have the risk, and they are paying. And this is actually seen in the contemporary systems. If you buy Microsoft software, they will immediately ask you to buy maintenance service, because even for the contemporary systems, Microsoft has to sustain the technology, because it keeps changing all the time. If you go and buy a system from Oracle, the same thing. They're going to charge you 20% of overhead just for the maintenance. Why? Because the contemporary systems need to be patched. So the same thing is going to happen with the legacy systems. The cost will be there. Okay. So now really the question is, the question now is, how do we reduce the cost of IT so that we can have this dream position where any document under the sun can be open no matter what? Okay. So how do we get there? There was also discussion before about the value of digital. It's really, really hard to assess what the value is for something in the future. And some proposals were already given at the beginning of the day, saying we need to become and think like a business people. We need to see how we can extract in the short term enough of the value so that we can support the long-term goals. Okay? So essentially that is the strategy. And it just happened that the cloud paradigm, because of the lower IT, may be a good one. I'm not saying it's the perfect one. I'm just saying it might be a good one because it lowers the cost of many, many things. That doesn't, of course, exclude all the issues that we already heard about. Okay. Just to bring home a little bit how the ecosystem looks like and where we are at the moment. This is the business ecosystem now. We have IT industry marching forward in the blue box. They basically want to bring innovation to the market continuously. Then we have content owners, content creators. So I'm the one. I want to write a book. I buy Office, and I create a content. And then at the end of the story, I pass this book to the libraries or archives. I say, please keep it forever. And if you just look at a little bit the cost distribution, the IT industry, of course, they recover the cost immediately. As soon as they sell me the license or service, they recover the cost. Otherwise, they wouldn't be in business. I actually have a risk. If they move on too fast, and I do not get the return on investment on my book before they move the format, then I'm done because I can't access it anymore. So really the content creators and owners, they're trying to capture the value as soon as possible. But the problem is that libraries and archives get it. The memory institutions are there to incur the cost. Because for them, it's much harder to create the value at that point. And it's worse because it's not only about value, it's really about the risk management. Okay? And fundamentally, it's about influence. The consumer has some influence on Apple's and Microsoft's and so on because they won't buy a product. Or they feel betrayed and say, well, I'm not going to take your software if you keep leaving me behind all the time. But what would libraries and archives say? Because they have to negotiate this for 20 years or 30 years. They won't be listened to. That's this fundamental problem. So where is now then, where's the critical bit? when it comes to generation of value, we really need to do it together. And basically, this is what this is showing. The value needs to be extracted across the shareholders. This is the main message. Thank you.
Thank you, Natasa. We'll take questions at the end of, once everybody's